Hi all, welcome to new class. Today's class is the continuation of network theorems. So let us study the reciprocity theorem. So this is second theorem. So first one is we have studied about superposition theorem. Next is reciprocity theorem. If we apply some input to a circuit which consists of resistors, inductors, capacitors, etc., the ratio of response, that is the output, in any element to the input are constant even when the position of input and output are interchanged. This is reciprocity theorem. Let us study this theorem in detail. So consider this network. Here A dash denotes the input terminals and B dash denotes the output terminals. The application of the voltage across A dash produces current I at B dash. Now, if the positions of sources and responses are interchanged by connecting the voltage source across BB dash, then the resultant current at the terminals A dash will be I. According to reciprocity theorem, the ratio of response to excitation is same in both cases. That is, the ratio of output to input in both the cases will be same if we interchange the input and output positions. This is called reciprocity theorem. Let us do problems to understand this reciprocity theorem. Let us do a problem. Verify reciprocity theorem. So this is the network given. So here a voltage source is there and I is the current through that 2 ohm resistor. So we have to first find the value of current. That is, here the output is current through the 2 ohm resistor. Then in the next step we have to interchange the positions of output and input. So let us draw the circuit again. So here this current we have to find. So here we can use the mesh analysis by inspection method. So first of all mark the currents. Let I1 and I2 be the currents. Then by inspection method we can write, that is, in R into I is equal to V form we can write, that is, here the self resistance is 5, then mutual resistance is -3 because I1 and I2 opposite direction. So here also -3. Then here the self resistance is 7 into I1 into I1 I2 equal to, here voltage is 20 because current direction is same, and here 0. Then we have to find the value of this current, that is current through 2 ohm resistor, that is I2. So for that I2 is equal to delta 2 divided by delta. So delta is determinant of R matrix, that is 35 minus 9, that is equal to 26. Then delta 2 equal to changing the second column elements with the voltage elements, that is 0, then plus 60 equal to 60. Then find the value of I2. That is I2 is equal to 60 divided by 26. That is equal to 2.3 ampere. So this is the first case, that is I is equal to, that is the response I is equal to 2.3 ampere. So this is the first case, I is equal to 2.3 ampere. Now we can interchange the positions of input and output. So after interchanging the positions of input and output, that is here voltage source is here and this is the current I. So here we have to find the value of current I through this 2 ohm resistor. So for that, here also we can use the mesh analysis by inspection method. For that, here this is the voltage source. So let this current be in this direction and this is I2. We have already marked as I2 and here the current direction is in this way, that is I1. Now by inspection method we can write self resistance is 5. So 5, then here mutual resistance is -3, then here the self resistance is 7, I1 I2 equal to, here voltage source is 0, then 20. Now we can find the value of I1. So I1 is equal to delta 1 divided by delta. So for that find delta. So delta is equal to same as that is 26. So delta is equal to 26 and delta 1 is equal to changing the first column elements with the voltage value elements and we will get 0 plus 60, that is equal to 60. Then I1 is equal to delta 1 divided by delta, that is 60 divided by 26, which is same as that case, that is 2.3 ampere. So I here also equal to 2.3 amperes. So in both the cases we got the response equal to, that is here response is current. So current is equal to 2.3 amperes. So reciprocity theorem is verified. Let us do another problem. Verify the reciprocity theorem for this network. So this is the network given and here the source is a current source. So here output is the voltage across the 3 ohm resistor.
So here input is current source.
Output is, we have to find the value of voltage across the 3 ohm resistor. So for that, voltage across 3 ohm resistor is current into 3. So for that we have to find the value of current through the 3 ohm resistor. So current through the 3 ohm resistor is, here we have given the current source. So we can find by using current division rule, that is total current, that is 10 ampere into resistance through the other branch. So these two are in parallel. So we can find the current through 3 ohm resistor using the current division rule, that is total current into resistance through the other branch divided by total resistance. Total resistance means here in parallel resistance. So that is 3 plus 2, that is 5 and that is equal to 4 ampere. Then we can find the value of voltage across the 3 ohm resistor, that is current 4 into 3, that is equal to 12 volt. So this is the first case. Now we can interchange the positions of input and output. And here there is a current source. So while interchanging the position of this current source to the output position, we have to put this current source in parallel to the resistor. So after interchanging the current source to the output position, we will get like this. That is, this current source we have to put in parallel to the resistor. So here that is the input and this is the output. So output here means the voltage across these terminals, that is here this is open, so we can find the voltage across this 2 ohm resistor. So voltage across this 2 ohm resistor is equal to current into 2. Then we can find the current through this 2 ohm resistor. Current through the 2 ohm resistor is, here again we can use the current division rule, that is total current into resistance through the other branch divided by total resistance 2 plus 3, that is 5, equal to, here we will get 6 ampere. Then we can find the value of voltage, that is voltage across the 2 ohm resistor is equal to 6 into 2, that is equal to 12 volt. So in both the cases we can find the ratio of current to voltage or voltage to current, that is ratio of current to voltage is equal to, here 10 divided by 12, that is equal to 0.833. So in both the cases the ratio of output to input or input to output is same. So reciprocity theorem is verified, or we can say in both the cases the output is same. The reciprocity theorem is verified. Let us do another problem. Verify reciprocity theorem. So this is the given network. So here this is the voltage source. Then output is, we have to find the current through the resistor. So here also by mesh analysis by inspection method we can write. So let I1 and I2 be the currents. So here we have to find the value of I, that is the current through the 5 ohm resistor. So by mesh analysis we can write self resistance is 6, then minus 4, here also minus 4, then 12 into I1 I2 equal to 10 0. Now here we have to find the value of I2 only, that is we have to find the delta and delta 2. So delta is determinant of this one, and that is equal to 72 minus 16, that is equal to 56. Then delta 2 is equal to changing the second column elements with the voltage elements. So we will get 0 plus 40 equal to 40. Now we can find the value of I2, that is I is equal to I2 is equal to delta 2 divided by delta, and that is equal to 40 divided by 56, and that is equal to 0.71 amperes. So this is the first case. Now we can interchange the positions of input and output. So by interchanging this voltage source to the output, we have to put in series to the resistor. So this is the second case, that is we have interchanged the position of voltage source to that side. So let I2 and I1 be these two currents. Then here we have to find the value of I1. So for that, by inspection analysis, that is mesh analysis by inspection method, we can write here self resistance is 6, then minus 4, here also minus 4, then here 12 into I1 I2 equal to here 0, then 10. Now we can find the value of delta and delta 1. So delta is equal to 72 minus 16, that is 56. Delta 1 is changing the first column elements with the voltage elements and find the determinant. So we will get 0 plus 40 equal to 40. Now I is equal to, I1 is equal to delta 1 divided by delta, that is equal to 40 divided by 56, and that is equal to 0.71 amperes. So in both the cases the response, that is the current is same. Now we can find the ratio of voltage to current, that is 10 divided by 0.71 is equal to 14.08. So here voltage divided by current is equal to 14.08. Here also voltage divided by current is equal to 14.08. So in both the cases the response is same and the ratio of voltage to current is same. Hence the reciprocity theorem is verified. So that is about the reciprocity theorem. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.